This lesson is over finding the greatest common factor. The greatest common factor is the largest factor that two or more numbers have in common. So we are going to find the greatest common factor of 40 and 64. Factors are the facts, the multiplication facts that equal that number. So factors of 40 would be 1 times 40, 2 times 20, and I have to ask myself, does 3 work? Can 3 be multiplied by anything to get 40? And the answer is no. So 4 times 10, 5 times 8, 6 doesn't go into 40, 7 doesn't go into 40, and then we're at 8. So we know that we have all of the factors of 40. Some people like to do a factor rainbow just to show that they got all the factor pairs. 1 times 40, 2 times 20, 4 times 10, and 5 times 8. Alright, now let's list the factors of 64. I have 1 times 64. It's even, so we know 2 works. 2 times 32. 3, I know that 3 doesn't work because the divisibility rule for 3 is if the sum of the digits is divisible by 3, then the number is divisible by 3. And 6 plus 4 is 10, and 10 isn't divisible by 3, so I know 3 doesn't work. But you could also just work out the long division, and if you have a remainder, then that means the number is not a factor of it as well. 4. Okay, so let's test 4. 64 divided by 4. 4 goes into 6 one time, with 2 left over, and 4 goes into 24 6 times. So that means 4 times 16 is 64, and we have none left over, so we know that is a factor pair. It doesn't end in a 5 or a 0, so we know 5 is not a factor. 6 isn't a factor because 6 times 10 is 60, so 6 times 11 is 66, that doesn't work. 7 times 10 is 70, 7 times 9 is 63, so that doesn't work. 8 times 8 is 64. So we know that we've listed all of the factor pairs. You don't have to write the 8 twice, you just have to, one time is fine. And you can do your factor rainbow again here to make sure that you get every factor pair. 1 times 64, 2 times 32, 4 times 16, and then you have your 8 times 8. Alright, so we've listed all the factors of each number. Now we need to find the greatest common factor. Let's see, they have 1 in common, 2 in common, 4 in common, 8 in common, no 16, no 32, no 64. So here, 8 is our greatest common factor. Greatest common factors can help us when we need to simplify fractions, use the distributive property, and solve word problems. So in this example, I'm going to show how you can simplify fractions using the greatest common factor. I used the same numbers from the first example. So we have 40 over 64, and we saw that in the first example, the greatest common factor was 8. So if I divide the numerator and denominator both by 8, I get the simplified version of this fraction. So 40 divided by 8 is 5, and 64 divided by 8 is 8. So 40/64 is equal to 5/8 in its simplest form. Alright, in this example, we're going to show how greatest common factor, it can be used with the distributive property. So example 3 says, rewrite 60 plus 20 by factoring out the greatest common factor. So first I need to list my factors of 60 and 20 that's all the factors of 60. Factors of 20. So I can see here my greatest common factor is 20. So that is the factor that I'm going to factor out. I'm going to write that on the outside of the parentheses. And I'm going to ask myself, what can I multiply 20 by to get 60? And 20 times 3 is 60, and 20 times 1 is 20. So that means 60 plus 20 is equal to 20 groups of 3 plus 1. All right, the next example says rewrite 6 groups of 4 plus 2 without the use of parentheses. And here we're going to distribute the 6 to the 4 and 2. So we have 6 times 4 and 6 times 2. 6 times 4 is 24. 6 times 2 is 12. And you can just, check to make sure that works in each problem. 20 times 3 is in fact 60. 20 times 1 is 20. Word problems that require you to find the GCF may involve grouping or dividing. So in this example it says, Mr. Advansky is packaging items to give his students. He has 48 pencils and 30 notebooks. He wants each package to contain the same number of pencils and the same number of notebooks. What is the greatest number of packages, supposed to say Mr. Advansky, can make without having any items left over? Alright, so let's first list all of the ways that the 48 pencils can be divided. You could have one group of 48. You could have two groups of 24. 48, 8 plus 4 is 12, so 3 does go into it evenly. So let's see how many times. 16 times. So 3 times 16, 4 times 12, and then 5 doesn't, and then 6 times 8. I'm going to list those out over here. So these are all of the different ways that 48 can be divided evenly. So let's see how many ways the notebook can be divided evenly. I have 30 notebooks. So you could have one group of 30, two groups of 15, three groups of 10, 4 doesn't work, and then 5 groups of 6, and I have all of the factor pairs. So let's see what is the greatest number that both can be divided evenly. They both have a 1, so we could put them all in one group. They both have 2, both have 3, don't both have 5, they both have 6, no 10, no 15, no 30. So the greatest way that these could be divided evenly is into 6 groups with none left over. So the greatest number of packages that Mr. Advansky can make without having any left over is 6 packages. So my question is, if he makes 6 packages, how many pencils would be in each package, and how many notebooks would be in each package? Alright, thank you for watching my video.